Let us discuss this problem. If X is a Poisson variate, Poisson distribution, Poisson random variable, Poisson variate, everything is same, Poisson variate, such that probability of X equal to 3 equal to probability of X equal to 4. Find lambda. You are asked to find lambda value. And what is given? Probability of X equal to 3 and X equal to 4 are same. First, you write the probability mass function for Poisson distribution. E power minus lambda, lambda power x by x factorial, where x equal to 0, 1, 2, 3, etc. We are going to find out lambda. And what is the condition given? X equal to 3 is same as probability of x equal to 3 is same as probability of x equal to 4. So in the previous formula, you put x equal to 1, x equal to 3. X equal to 3 means e power minus lambda, lambda cube by 3 factorial. Then substitute 4. Then you simplify. I will explain the simplifying the side by side. So left hand side is 3 factorial, right side is 4 factorial. You can cancel certain terms on both sides. I will explain. 3 factorial means it is 1, 2, 3, 1, 2, 3. 4 factorial means it is 1, 2, 3, 4. We can cancel 1, 2, 3, we can cancel 1, 2, 3 on both sides. And also we can cancel e power minus lambda. The remaining terms, denominator we have a 4, you bring 4 to the left side, 4 lambda cube. Right side lambda power 4. So if we bring this term to the other side, lambda power 4 minus 4 lambda cube is equal to 0. Taking lambda cube outside, lambda equal to 0 or lambda equal to 4. But lambda equal to 0 is not possible because lambda is a positive quantity. Therefore, the answer is lambda equal to 4. So your lambda must be a positive number. This is actually, we can solve the same problem using binomial distribution also, because n is very large, p is very small. Both the answers are more or less same. We will do in a factory producing razor plates. There is a small chance of 1 by 500 for any to be defective. For the defective item produced by a machine is 1 by 500. Very, very small number P. The plates are supplied in packets of 10. So each packet will have 10 plates. So my n value is 10. Use Poisson distribution to calculate approximate number of packets containing no defective, 1 defective, 2 defective plates, respectively in a consignment of 10,000 packets. Out of 10,000 packets, how many packets are no defect, 1 defect, 2 defect? Just to find the probability, then multiply with 10,000. You may get the answer. Here, for using Poisson distribution, we need lambda. So binomial distribution is the limiting case of Poisson. In that explanation, we have given lambda equal to np. N equal to 10, P equal to 1 by 500. If it is simplify 0.02, the lambda is 0.02. 10 divided by 500. So lambda value is ready. Immediately write the probability mass function. So your probability mass function is e power minus lambda, lambda power x divided by x factorial. Replace your lambda value, 0.02. In this probability mass function, we have to find out the probability, then you multiply with 10,000. That will give the approximate number of packets with no defective will be arrived. Now let us find out the probability for no defective. Probability of x equal to 0. X equal to 0 means in the probability mass function, replace x equal to 0. So e power minus 0.02, e power minus 0.02, 0.02 power x, x is 0. There would be 0 factorial. Please remember that 0 factorial value is 1. 0 factorial is not 0. 0.02 power 0 is 1, 1 by 1. So we can omit that term, e power minus 0.02. If anybody have calculator, you can take the calculator. I will tell how to find e power minus 0.02 with the help of calculator. From this step to this step, how we can get it. Scientific calculator you must have. The business calculator is not useful. In the scientific calculator, how to find e power minus 0.02. Shift ln. Press shift button and ln button. Then your calculator will display e. Your calculator will display e. Then press opening bracket. Within the bracket, you put minus 0.02. Close the bracket. Minus 0.02. So you are get 0.9802. 0.1986 something. So this is the probability for x equal to 0. The probability for a packet being defective. How many packets we can expect out of 10,000 being defective? So n into probability x equal to 0. If you multiply 9802. Zero defective means good. Out of 10,000 packets, 9,802 are good packets, no defective. Next, x equal to 1. 1 defective packets. X equal to 1 means 1 defective packet. Replace x value 1. E power minus 0.02. 0.02 power 1 divided by 1 factorial. In the same way, use calculator. You make it 0.0196. If any student got some other answer in the calculator, tell me, I will explain. So when attending classes, you can also keep your calculator with you. For small calculations, you do practice. So with the practice only, you can remember mathematics. Simply reading may be useful for English. Simply reading a problem content may be useful for English subject. For mathematics, you must work out. Calculations, everything, you must practice yourself. So the probability for a box becomes 1 defective. 0.0196. Multiply with the 10,000, we get 196. Then probability x equal to 2. Probability of x equal to 2 is a very, very small number. 2 defective items, 0.000196. So out of 10,000 packets, how many packets we can expect? With the 2 defectives, it is very rare. 1.96, approximately 2. Let us solve this problem. Between the hours 2 p.m. and 4 p.m., the average number of phone calls per minute coming into the switchboard of a company is 2.35. So in big offices, one telephone operator will be available. Whatever the calls are coming inside, the telephone operator will attend, and the telephone operator will forward the call to the respective person. The number of phone calls, average number of phone calls received is 2.35. So in Poisson distribution, lambda, the mean equal to lambda. Mean, variance, everything is lambda. Average number of phone calls is given. So you are given lambda value. Lambda equal to 2.35. Between 2 to 5, 2 to 4, average number of phone calls per minute. Every minute received is 2.35. So the number of calls received during 2 to 4 p.m. divided by 120 minutes. There are 2 hours, 120 minutes. So if your number of calls divided by 120 minutes, then it will be 2.35. So this number is given. Find the probability that during one particular minute there will be at most 2 phone calls. So the information given is for every minute. Every minute we receive 2.35 calls. So lambda equal to 2.35. First we will write the probability mass function. Nowhere Poisson distribution word is mentioned. So based upon the nature of the problem, you decide. I cannot go for binomial distribution. Binomial distribution means I am in need of success failure concept. So this is not in that case. The probability mass function. Every problem you must write the probability mass function. The probability mass function of the Poisson distribution or Poisson random variable, both are same. Poisson random variable. Probability of x equal to x, it is p of x, e power minus lambda power x divided by x factorial. Here lambda value minus lambda is minus 2.35, e power minus 2.35 into 2.35 power x divided by x factorial. So this is the probability mass function. So probability for 0 calls in 1 minute. What is the probability for 0 calls means put x equal to 0. If you are putting x equal to 1 calls like that. Now read the last line. Find the probability that during 1 minute, one particular minute, there will be at most 2 phone calls. Number of phone calls is at most. Maximum 2 phone calls. Maximum 2 phone calls means number of phone calls cannot go beyond 2. So you are asked to find the probability of number of calls less than or equal to 2. Required probability. You understand the word problem is very simple. Required probability of per minute number of calls is at most 2. At most 2 means maximum 2. Maximum 2 calls means it may be minimum. It should not 3, 4 like that. So x is less than or equal to 2 is correct. In the probability mass function, your x values are 0, 1, 2, 3, 4, etc. So x is less than or equal to 2 means there are 3 terms we have: x equal to 0, x equal to 1, x equal to 2. So we are need to find out probability for x equal to 0 calls. In a particular minute, 0 calls probability, 1 call probability, 2 calls probability. In the probability mass function, you substitute your x value 0. In this formula, you substitute x equal to 0, x equal to 1, x equal to 2, simplify. So e power minus 2.35 into 2.35 power 0 divided by 0 factorial. This is my x equal to 0 case. Next, put x equal to 1 case. E power minus 2.35 2.35 whole square divided by 2 factorial divided by 1 factorial, sorry, power 1 by 1 factorial. Next 2, e power minus 2.35 whole square divided by 3 factorial. So the first one is for x equal to 0 probability. Next one is for x equal to 1 probability, x equal to 2 probability. Let us simplify, then we will use calculator. As far as possible, always take common factors outside. If you have any doubt in simplification, you are ready to ask. E power minus 2.35 is appeared in everywhere. You take that term outside. After taking the common factor outside, the first term is 2.75 power 0. Power 0 means 1. 0 factorial is 1. So the first term is 1. In the first term, the remaining term is 1. In the second term, 2.35. In the third term, 2.35 square divided by 2. So I can simplify this problem. If you are having calculator, you can take the calculator. I will explain how to use calculator to get this number. First, e power minus 2.35 you type. How can I do? Shift ln, press shift button and ln button. Your calculator will display e. Then opening bracket minus 2.35. Close the bracket. So your calculator will display e of bracket within bracket minus 2.35. This is e power minus 2.35 into another opening bracket 1 plus 2.35 plus 2.35 square by 2. 2.35 press x square button divided by 2. Then close the bracket. So your calculator will display e of opening bracket minus 2.35 into symbol opening bracket 1 plus 2.35 plus 2.35 whole square divided by 2, close the bracket. Now if you press equal to, that will give the required answer, 0.5828. Always write the answer up to 4 decimal places. So answer for this problem, 0.5828.